In this example, we want to look at writing a function to model a certain physical problem. So the problem here is I have a 12-inch long piece of wire that I want to cut once to make two separate pieces. I'm then going to take each piece and wrap it into a square. I want to write a function that computes the total area of these squares that I get in this way. Let's draw a picture out to start. It's usually a good place to start is draw a picture. The picture I have here is my 12-inch piece of wire. I'm going to cut it once to make two separate pieces. Now the part that I can choose here is where I make this cut. So I'm going to label this length here as x to denote where I'm going to make this cut. Now if that length is x, this side length here is 12 minus x. When I make this cut, I now have two pieces of wire, one of length x and one of length 12 minus x, that I want to wrap into squares. Now if they're squares, what do I know? Well, I know all sides are the same length, and this length of wire must make up the perimeter. The perimeter of a square is 4s. That means for each case, the side length must be 1/4 the length of the wire. So in this case, I have a side length over here of x over 4, and over here, I have a side length of 12 minus x over 4, or 3 minus x over 4. So if that's my side length, the area for this first square is side length squared, which is going to be x squared over 16. And for the other square, I will get that the area is 3 minus x over 4 squared. And then my total area will be the sum of these two. So total area is just adding these two together. X squared over 16 plus 3 minus x over 4 squared. This would be my area function, a of x. This is how you go about finding a function for the total area you get from these two squares when you cut a wire this way, by setting up a picture for what they look like, working out what it has to be, and then writing out a total function for the area of the situation.